Hmm. Okay, I guess everyone is here. So let's get started without any further ado. In today's class, as discussed, we'll be going with this new topic called networking fundamentals. One of the important prerequisites required for cybersecurity. So let's understanding what networking is, what are IP addresses, and again, we'll also be learning about some important protocols and networking and the categories of IP addresses and all that stuff. Okay, quite important as we progress. When every single class will be dealing with IP addresses. So it's important to know what these are. Okay. So let's get started. So when you talk about networking fundamentals, there are three important definitions to know. What is networking, what are networks, and what are hosts. When you talk about networking, this is the practice of connecting information devices with each other. So in an organization, you might have multiple different endpoints. You have routers, you have firewalls, you have computers or desktops, computers, you have your IDS, IPS systems, you have your IP cameras, you have your printers, whatnot. So the practice of connecting all of these devices with each other so that they can share information or communicate with each other is called as networking. Okay. And that collective group of those devices or the collection of those interconnected devices is called as a network. So whenever you say there's a network, in that network, every device can communicate with each other. That's an important point to note. So in a network, whatever device is connected, all of those devices are able to communicate with each other. Okay. And when you have each of these devices in the network is referred to as a host. So host refers to any device connected to that network that can transmit or receive data. Okay. Just like how we humans have our names basically to identify each other or address each other, these devices also have names, and those names are IP addresses. Okay. So to define it, each host on the network has a unique identifier and to identify each device, and that is known as an IP address. And these IP addresses also allow communication to occur between the hosts. Okay. Now, when these were invented by the US military in the late 1950s or so, there were multiple versions of it, experimental versions, IP version 1, IP version 2, IP version 3. They were not, again, successfully working out. What properly worked out was IPv4, Internet Protocol version 4. And we're still using IPv4 addresses even in today's world. And this IPv4 address has a few important properties to it. So let's talk about those properties now. Okay. So firstly, your IPv4 address is a 32-bit address. What I mean by 32-bit address is that it contains 32 zeros and ones in it. A bit is the smallest data value a computer can hold, and it can either be the value of 0 or it can be the value of 1. Okay, so your IPv4 address consists of 32 zeros and ones in it. And this entire 32-bit address again is divided in four equal parts, where each portion contains 8 bits in it, and each of that 8-bit portion is called as an octet. Octa represents 8. Okay. And each of this octet of 8 bits each is separated by a dot symbol. So this is what your typical IPv4 address looks like in the language of zeros and ones, which is also commonly known as the binary language. Okay. So as you can see, there are 8 bits here. 11000000, then a dot, then another 8 bits here, then a dot, then another 8 bits here, then a dot, and then another 8 bits here. Okay. So what you see here is called the binary numbers from again ranging with just zeros and ones. Okay. But we humans don't understand binary so well. What we regularly use are decimal numbers, numbers from 0 to 9. So now I'm going to show you how do you convert any binary number to a human readable decimal number. So this number 11000000 is actually equal to 192. This number 10101000 is actually equal to 168. This number with all zeros is simply equal to 0. And this number 00001010 is actually equal to 10. So now I'm going to show you how do you convert these binary numbers into human readable IP address numbers with decimal numbers. Okay. Exactly. Any questions or doubts up to this point? Anyone? Uh, one second. Amit, any questions? Lena, any questions? Arafat, any questions? Ravi Teja, any questions?
So it's
Sat,
fine.
VK, Venu.
Need little bit more explanation. So
On what? On what part, Venu?
like in generally any topic, like if you see IP address,
Yeah, we'll learn that. Don't worry. Again, we are just getting started. So now I'm going to explain how to convert these binary to decimal numbers. Then we'll talk about again what the different categories of IP addresses are, what are classes and them, what are public and private IPs and them. We'll cover all that slowly. Okay. So again, we're just getting started. So I'll explain it in much more detail slowly. Okay. So now let's
no.
talk about the conversion. Okay. So how do you convert a binary number like this to a decimal number? Let's talk about that. So that conversion is going to give you an understanding on the range of IP addresses. Like what's the first IP, what's the last IP in the IPv4 range. We'll get all that information. Okay. So let's talk about the conversion now. So let's say we have a number like this here. 10, 10, 10, 10. Okay, so I've written down an octet here of 8 bits. 10, 10, 10, 10. Now let's talk about how to convert this octet of binary numbers into a human readable decimal number. Okay, so to convert this number from binary to decimal, there are two simple steps. Okay, step number one, you write down all the values from 2 power 0 to 2 power 7 from right to left. So under each bit, you're writing down these values. So the rightmost bit has 2 power 0 under it, then there's 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So from right to left, you're assigning these values of 2 power ranging from 2 power 0 to 2 power 7. Now, if you specifically ask me why only 2 to the power everything, because this is a binary number. You only have two possibilities, 1 or 0. Hence, 2 power everything. The number of possibilities to the power of these numbers, 0 to 7. Okay. Now, once these values are written, then you multiply the lower value with the top bit and you add it till the end. Okay, so multiply the lower value with the top bit and add it to the next one. 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So when you perform that calculation, then you get the final decimal value. So that is how you can convert a binary number to a decimal number. Okay. So let's start calculating. Let me write down these values first. From 2 power 0 to 2 power 7. Anything to the power of 0 is always equal to 1. It's a mathematical rule. So 2 power 0 is 1. Excuse me. 2 power 1 is simply 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times, that's 16. 2 power 5 is 32, 2 power 6 is 64, and 2 power 7 is 128. Now that you have these values here, you can substitute them, okay, here and start calculating. So 2 power 0 into 0. 2 power 0 is 1, so 1 into 0 is simply 0 plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. Plus 2 power 2 into 0, 0 again. 2 power 3 into 1, 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. Okay. Now that you have all these numbers, you just add them up. 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer reads it as 10101010. That's how the computer reads it as or understands it as the number. Okay. This is the computer readable language and this is the human readable language. Is that clear, everyone? Any questions or doubts up to this point? How to convert a binary number to a human readable decimal number?
Yeah, so same thing can how we can convert like human readable to machine.
Same
Similarly,
thing. How can we convert what?
now 1010 we did the way, right? 0 2 1 something like that. So reverse way also how we can convert our
You would just have to divide it by 2. So basically, if you have this number
only.
170, you keep
Mhm.
dividing it by 2. And if you get a reminder of, again, if you get a reminder of 0, you put 0. If you get an odd number with a reminder of 1, you put 1. So if I just show you, if I just go
Yeah,
to a
same
graph.
number can get like the 1 0.
Sure. So for example, 170 in binary. As you can see, this is 10101010. But how did you get that? You just divide it by 2. Okay. So 172 by 2 is 85. Reminder is 0. So you put 0 there. 85 by 2, 42. There's a reminder of 1. 42 by 2, there's 21. There's a reminder 0. 0. 21 by 2, 10. There's a reminder of 1. 10 by 2, it's 5. Reminder is 0. 5 by 2, it's a reminder 2. Okay, there's a reminder of 1, sorry. Okay, 2 by 2, it's 1. Reminder is 0. Okay, and 1 by 2, that's 0 anyhow. Okay, so 1, 0, 1, 0, 1, 0, 1, 0. So you just divide it by 2. Okay, and that's how you get the number 170. That's the reverse order of calculating how to convert a decimal number into a binary number. Is that clear?
Yes, yes, yeah, got it. Thank you.
Right, Wayne. Perfect. Now, this is clear, guys. If the conversion from binary to decimal is clear, I have two more numbers here: 0 1 0 1 0 1 0 1 and all ones. And what I want you to do is, if you have a pen and a paper beside you, I want you to calculate and give me the final decimal answers for this. So, example one is 0 1 0, and the other one is all ones. So, take your time, no rush. Calculate these. I've written down the values from 2 power 0 to 2 power 7. Calculate and give me the decimal answers for example 1 and example 2. I hope the previous example was clear for everyone. Only if that slide was clear, you can perform this.
Yes, yes.
Uh, you can get the answers for these examples. So, yeah, perfect. Okay, take your time, no rush. Give me the answers, guys, in the chat box or via verbal communication.
So the first one is 85.
Okay, I've got the first one as answer of 85. Let's wait for the others as well.
It should be like 255. So
Oh, second one is 255. Okay, sure. Let's wait for the others' answers as well for a few more minutes. Perfect, guys. I've got very similar answers from everyone. So again, as discussed, the first answer is 85 itself. Okay. 0, 1, 0, 1, 0, 1, 0, 1. You'll have again to power 0 into 1, that's 1 plus 0 plus 4 plus 0 plus 16 plus 0 plus 64 plus 0. If you add all that up, you get 85. And for all ones, you just add all the numbers. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And when you add that up, you get the number 255. Now, the reason I've been explaining all this is so that you get the exact range of IP addresses. Now, if I had to get the first IP, all I have to do is put zeros everywhere. In the first octet, all zeros. In the second octet, all zeros. In the third octet, all zeros. And in the fourth octet, all zeros. When I put all zeros everywhere, the first IP we have in decimal value is simply 0.0.0.0. And if I have to get the last IP, all I have to do is put all ones everywhere. That's the maximum value attainable. So when you put all ones, the last IP is 255.255.255.255. So now we have a logical understanding of what the range of IP addresses are and why they cannot exceed beyond 255. Because in an octet, when you have 8 bits, and when you put all ones in the 8 bits, you get a maximum of 255 itself. You cannot go beyond that. Okay, so this is the exact IP range of the IPv4 addresses. Okay, and we have to count how many IPs are there in total. Each bit here has two possibilities, 0 or 1, and there are 32 bits in total. So the total number of possibilities would be 2 raised to the power of 32. Okay, so 2 into 2 into 2 into 2 into 2, 32 times. So 2 raised to the power of 32 is 4.3 billion IPs approximately. So when these IP addresses were invented in the late 1950s or so, they thought 4.3 billion IPs is a very large number. But fast forward to 2025, the population itself is the double of that, almost 9 billion people. And each person again basically can have multiple devices, right? So therefore 4.3 billion IPs would have never sufficed that way. Okay. So that is why these IP addresses are again categorized in different types. They are classes, they are public and private IPs, etc. etc. Okay. But before we cover all that, let's talk about the sequence of these IPs. We know this is the first IP, we know this is the last IP. What about the IPs in between? How do the IPs progress one after the other? Let's talk about that sequence right now. Okay. To understand the sequence of IPs, there are two simple rules again. Okay. Let me show this in the notepad file if possible. Yeah. Right. So to understand the sequence of IPs, guys, there are two simple rules. Rule number one, you will always start incrementing from the rightmost octet. What I mean by that is if we have the first IP here as 0000, then the next IP would simply be 0001. So the rightmost octet always increments by 1. Okay. So after 0000, the rightmost octet is 0001. Then you have 0002. Then you have 0003. Then 0004. This goes all the way up to 000255. Okay. Now after 000255, please note you cannot have something like 000256. This is not possible. Okay. So once it reaches the maximum value of 000255, then comes the next rule. After once the rightmost octet reaches the maximum value, then you move to the left octet. Okay. So after 000255, you have 0010. Okay. So this 255 cycles back to the first value 0, and the left octet now increases by 1. So you have 0010. Now after 0010, don't directly jump to 0020. Remember rule number 1, always increment the rightmost octet. Okay. So after 0010, you have 0011, 12, 13, 14, which goes up to 1255. And then you have 20. Okay. So if you see there's a pattern forming here. 00 to 0255. 10 to 1255. 20 to 2255. 30 to 3255, 40 to 4255, 50 to 5255, 60 to 6255, 70 to 7255. The pattern keeps on repeating again and again. And somewhere down the line, you would have 2550 to 255255. Once both these octets are full, they cycle back to zeros, and the next octet changes to 1. Okay. And you have the first cycle again, 00 to 0255, 10 to 1255, 20 to 2255. So the same pattern repeats again until 25502 to 255255. Once this 255255 is reached, then this 1 changes to 2. Okay. So this is the next pattern if you notice. 000 to 0255 Okay. Then 100 to 1255255. Then 200 to 2255255. 300 to 3255255. 400 to 4255255. Like that, the pattern repeats again and again and again. And somewhere down the line, you would have 25500 to 255 Once all these three octets are full, the last octet now, 0, changes to 1. Okay. And all these 255s cycle back to zeros. Okay. Now, whatever cycle repeated from the first IP, 0000, 0000, up to 0255, same cycle now again repeats from 1000 to 1255, again 2000 to 2255, 3000 to 3255, 4000 to 4255, and similarly down the line you would have 255000 to 255. That's the last IP address there. Okay, and that is how the IPs progress one after the other from the first IP till the last IP. Same sequence is written down over here. I know it's a bit overwhelming, but if you just go through the recording one more time, it might be a bit more easier to understand. Okay, so just two simple rules to remember. Always increment the rightmost octet first, and once the rightmost octet reaches the maximum value 255, only then go to the left octet. Okay, and while you're going to the left octet, reset the rightmost octet to 0. So the rightmost octet, once it reaches maximum value, it resets back to 0, and then the left octet increments by 1. That's rule number 2. Okay. Is that clear, everyone? Amit, Abhishek, Venu.
Yes, yes. But
Yeah,
one
sure. I mean, question: Why we when we see the IPv4 addresses, so
Mhm.
every time we see that 198, 168.
192, 168, I suppose, if I'm
Yes,
not wrong.
one.
Right. So
Yeah,
those are something called as private IPs. I mean, okay. So the one which you observe usually, the 192, 168. Even in my command prompt, if I type ipconfig, you see something like 192.168 0 dot something. So these IP addresses are the private IP addresses. So this entire range of these IPs, these 4.2 billion IPs, are divided in various classes again. So there's something called as class A, class B, class C, class D, and class E. And again, in each of those classes, you have two subcategorizations, public and private IPs. So class A has public and private, class B has public and private, class C also has public and private.
so I mean,
Class D and class E have public IPs.
so is it also possible that suppose some organization is using particular IP, and when they are not using that IP, after some time it lapses and then it's assigned to someone else, right?
Your voice is very low. Venu, can you please repeat the question? Hello. Hello. Was someone asking a question, guys?
Yeah, Shoaib, I'm audible, right?
Oh, Amit. Yeah, go ahead.
Yeah, so what I'm saying that suppose is it also possible that some organization is using particular IP and after they are if they I mean they start using and once they have uh, finished it, I mean once it got lapsed, then that particular IP got assigned to someone else. Is
No,
it
what you're
happened?
referring to there is something called DHCP protocol. We'll come to that as well. Don't worry, Amit, you're skipping a bit ahead actually. So we'll come to that.
Okay.
Why is your system only getting that 192.168 IP? We'll cover all that. So as mentioned, we are going in a sequential order here. Okay. So do not miss the flow. So again, when you're talking about that 190 to 168, if you notice, that is mentioned over here. You see this class C. In the class C, there's a private IP range called 192.168.0.0. So in your organization or in your home network, you usually use 192.168 for a certain purpose because class C is suitable only for small networks. So in your small network areas, okay, in your home networks, in your office organization networks, you use class C, which always begins with 192.168
No,
for the
so
private.
what my question is that if someone using particular IP, so
Mhm.
after some time, it may be possible. Is it possible that the similar, I mean, same IP got assigned to someone else once that got
Yeah, can be
lapsed?
assigned. Basically, you won't get that
Okay,
IP anymore in the network. So that is what the
okay,
DHCP protocol works like. Okay, so that is way more ahead. If you go much
okay,
more
okay,
ahead,
no problem.
there's
Okay, okay,
something
thank you.
called DORA process. With the DORA process, every system in the network gets a unique IP. Okay, so your DHCP server in your home network or in your organization has a pool of IPs. From that pool, each system gets a unique IP. Okay, and this pool of IPs are assigned to each system for a limited time period called a like lease time. After the lease time, if your device is not available, that IP which was assigned to your device can go to another device. Okay. So, but if your device is actually still available in the network even after lease time, then it doesn't go. It stays the same. If your device gets disconnected during the lease time and after the lease time expires, then that IP goes back to the DHCP server and it can be assigned to any other device. Okay. So that's called DHCP protocol. We'll come to that later on. Okay. It's way further ahead. Okay. So let's go in a sequential order. Okay. But for now, I hope I've answered your question.
Yes, yes, right, thank you.
Hmm. Oh. Right. So here we are. We have
Yes,
talked about the sequence of IPs. Oh yeah. Was someone asking another question?
yes, yes. So this 0.0.0 is someone really using these IPs or just for reference these are registered?
The first IP 0000. Wait, is what you're asking?
Yes, yes, yes.
No one uses that IP. Those fall in the public IP category. Okay. After that, after the zero dot network, you have the one dot network. From there is where the public IP begins. Actually, no one uses the zero dot subnet altogether. It's just excluded completely. But yeah, the one from the one dot to up to the nine dot, it's the public IP range. So those are available with the ISPs again for internet connectivity.
Okay, same thing for the same 255.255 dot. The last one also.
Those are class D and class C. Those are used, but again, they are used by special organizations. So again, research and development organizations, military organizations, your government forums and stuff. All of those are using class D and class C, which falls in 255 category
Okay, so the whole world IPs are organized in between these range only, right?
in this range only. There's
But
one more
just
categorization called IPv6 also, but that's a much
okay,
more advanced classification. We'll cover that later. The older
okay,
classification or the ones which we are currently using as well are IPv4 with the same exact range. And this range is constant, it's fixed. This will never change.
okay. Thanks.
Right. Moving on. So again, as mentioned, this entire range is divided in various classes and various categories, guys. Today we'll discuss what public and private IPs are. In the next session, we'll discuss what classes are as well. Okay. So as mentioned, the entire 4.3 billion IP addresses are divided in these five classes: class A, B, C, D, and E. And each class has its own relevance. We'll cover that later. But again, in each class, you have these two subcategorizations, public and private IPs. Let's talk about that. To understand this public and private IP categorization, let's take the example of our home network itself. Now, in our home network, we might have a Wi-Fi router, and to that Wi-Fi router, we might have these other devices interconnected. You could have your laptops, your smartphones, your smartwatches, your smart TVs, whatnot, all connected to the Wi-Fi router. Now, all of these devices are a part of your intranet. Intranet is your local private network. Okay. And in a local private network, you always use private IPs. So when one device wants to communicate with another device in the local network, in your own home network or in your organization network, then for that you always use something called private IPs. These are the IP addresses used in the local intranet. Okay. But when any of these devices wants to communicate with the public network, which is the internet, for that you need a public IP. Okay. And this public IP is always provided by the ISP, Internet Service Provider. Organizations like Act Hibernate, Hathway, Ticona, Reliance Jio, Airtel, all of these are ISPs, Internet Service Providers. Okay. They have all the public IPs with them, and they'll assign one public IP to you to access the internet. And that public IP is shared across all the devices in your network. Okay. So each device gets a unique private IP, and all of them get one unique public IP, okay, which is collectively shared among all these devices to access the internet. So if your phone wants to communicate with a website like google.com, let's say, first it sends the packet from your phone to the router with the private IPs. Router is capable of transmitting data across two different networks. So between the private network and the public network, you'll always have a router to communicate. Okay, so your router shifts the packet from the private interface to the public IP interface. And with that public IP, it reaches the internet ISP, and then it travels across different servers on the internet, and then finally reaches google.com over the internet. So whatever traffic needs to flow over the internet, that always happens with public IPs allocated by the ISP. And if you have to check what your public IP is, you can just go to your browser and search here for what is my IP. And sometimes it's visible over here itself, or you can click on any of these websites here, and that shows the exact public IP. So this is the public IP that my devices are getting in my region for my home network. And on the other hand, if you have to check what private IPs are, as mentioned, these are the IPs used in your local networks. So every unique device in your own local private network gets a unique private IP. These are not directly accessible from the internet. You can't connect to the internet directly with just a private IP. You need a public IP for that. Okay. Private IPs only allow devices within the same local network to communicate with each other. So in an organization, if you have like 100, 200 PCs, and if you want to communicate among each of these, if you want to share files among each of these, you can use your private IPs for that. You don't need a public IP for that. Okay. When you want to communicate with the internet, only then you need a public IP. And if you have to check what your private IP is in your Windows system, you can open up your command prompt and run a command here called ipconfig. And that shows your system's private IP. Okay. So why am I specifically getting 192.168 here? Why am I specifically getting 49.204 here? Is because each of these public and private IPs have their unique ranges in each class. And we'll cover those ranges in the next session. Okay. What is the range of class A, B, C, D, and E? And in those classes, what is the specific range of public and private IPs? We'll cover that. And then we'll understand the relevance of each of those classes. Okay. Why do we have 5 separate classes? What's the relevance of each class or the importance of each class? We'll cover all that in the next session, guys. Okay. So again, for people who have not joined the session yesterday, this is a part of the Certified Ethical Hacking course, guys. This is the first class actually in the course. We are covering networking fundamentals. It's for a duration of 35 to 45 days where we have classes from Monday to Friday, every day for 1 hour each. Okay. Since these are demos, I'm taking slightly shorter sessions because not everyone might be available for the demo. So we'll be having slightly shorter sessions compared to our regular classes. Okay. But once we start the sessions, they're going to be longer durations, almost 1 hour, okay, to cover all these other practical stuff. Okay. So if you have any queries, please refer back to the recordings. These sessions are being recorded and they're uploaded on YouTube itself. You can just search for cybersecurity DurgaSoft and you can access the recordings there. Okay. So yeah, any questions or doubts for today's session before we exit? Amit, Abhishek, VK, Venu, Ravi Teja, Arafat, Leena Das.
So
No,
if
sir,
we miss,
nothing.
yeah, if we miss any class, will we be getting any recordings for that
Yeah,
session?
definitely. Again, as mentioned, once you register for the courses, for this
Okay.
course, you with your email ID, you'll be getting all the recordings to your Google Drive for Ravi Teja. So in your Google Drive shared with me folder, you'll have access to all of these recordings directly.
Okay. Okay. So the course duration will be 45 days, right?
35 to 40. Okay, depends. Again, just in case if you're missing out some sessions in between, but yeah, it should be done in 40 days, max to max. Any other questions, please?
Just not to this class. So in our course content somewhere it's mentioned Android testing also covered. Same way, Apple iPhone testing also will be covered. Or only
No,
Android?
iPhone is not included, because again, for that you need a separate course itself. This for iPhone, for Apple related devices is altogether a separate course, which is not included as a topic in CH. But don't worry, as a bonus content, I'll share the tools which we use for iOS pen testing, and you can do some research on that. Okay, but it's altogether a different course itself.
Okay, you will provide training for that as well.
Yeah, I'll provide that resources. Don't worry.
Okay, cool. Yeah, thanks. Thank you.
No problem. Any other questions, guys? Okay. Assuming no questions, please do join the session tomorrow at the same time. We'll be covering all the other important concepts as well left out in our networking sessions. Okay. So
Okay.
have a good day. Thanks for joining the session today. We'll connect back tomorrow. Bye-bye.
Thank you.
Yeah, thank you. Bye.
Thank you, guys.